Good evening. Good evening, everyone. Good evening, everyone. My name is Len Shustak. I'm the chairman of the board of the Computer History Museum. Well, thank you. On behalf of the board, the employees, the staff, the volunteers of the museum, I'd like to welcome you to the 22nd year of our Fellows Awards. I am guessing by the fact that you're here that a lot of you are museum goers. And if you think back to museums like the American Museum of Natural History in New York, what do you see in the lobby? Dinosaurs, right, dinosaurs. I mean, there are dinosaurs in museums all over the world, from Minnesota to Chicago, from London to Russia. They all have dinosaurs in the lobby. And of course, we have dinosaur envy, right? So not wanting to be outdone, we have our own dinosaur in the lobby. Now, ours is not from the pre-Cambrian era, it's from the pre-computing era, right? This, of course, is the Babbage difference engine that's downstairs. I'm talking, of course, about this giant mechanical monstrosity, right? It's 11 feet long, it weighs 9,000 pounds, it's got 8,000 bronze, cast iron, and steel parts. But better than a lot of the dinosaurs that are in other museums, it actually does something. It works, it moves, it computes, right? It's a live thing. Just like the dinosaur, though, the Babbage engine was an evolutionary dead end. It no longer roams the earth, and you can see it now only in museums. Actually, it's worse than that, because the Babbage engine never roamed the earth. Babbage never built it. He also never built his other very important engine, which was the world's first programmable computer, called the analytical engine. Babbage died a bitter and disappointed old man, and whose dream to do computations by steam, which is to say automatically, was put on hold for the next 100 years until the computer was invented again in the 1940s. As you probably know, the Babbage engine downstairs doesn't belong to us. It was commissioned by Nathan Myhrvold, formerly of Microsoft, from the Science Museum in London, who built it, for his personal collection, and it's on loan to us. It was supposed to have left for Seattle to his living room to join, by the way, the Tyrannosaurus Rex that he has in his living room in December. But I'm pleased to announce here today that we asked Nathan, and he agreed, for the Babbage engine to stay here for yet another year until December of 2010. Thank you, Nathan, wherever you are. Now, many more visitors will get a chance to see that rare sight. It's a rare sight that commemorates a remarkable intellect. He was a remarkable intellect, but one who essentially had no effect on establishing the computing revolution that we're enjoying today. So you might ask a reasonable question. If Babbage was a failure, why are we promoting his memory? Why do we enjoy demonstrating a machine that was built for the first time 150 years after it was designed? The answer is simple. We celebrate genius. We stand in awe of his accomplishments as a thinker and as a pioneer. We're inspired by his cleverness, by his methodical attention to detail, and his perseverance in the face of skepticism and criticism. These are the same traits that we celebrate in the 47 pioneers that we have made fellows of the Computer History Museum over the last 21 years, and in the 6 that we will make fellows tonight. These are people who, like Babbage, see a present need and invent a future that meets it. But unlike Babbage, our fellows have made the future that they imagined into a reality. They are successes. They have changed our world permanently and for the better. They have created a pedestal on which future innovation will build. And they are the inspiration for the next generation of pioneers that will be our fellows here in the future. We are honored tonight to have several of our previously inducted fellows here, and I'd like to ask them to stand as a group and be recognized. We have here, I believe, tonight, Gene Omdahl, Paul Barron, Gordon Bell, Doug Engelbart, Gordon Moore, and Chuck Thacker. Please give them a round of applause. Thank you, and thank you for being here to celebrate this year's Fellows. It's my great pleasure now to introduce the dynamic, passionate, and tireless CEO of the Computer History Museum, John Holler.
Thanks very much, Lynn. Thanks so much. And let me add my note of welcome to all of you tonight, ladies and gentlemen. This is traditionally the most sparkling evening in our calendar, literally, and we're delighted that you're all here tonight. Lynn, I think you look great in a tux. We don't get to see that very much. My old boss in Washington at PBS, Irvin Duggan, used to wear a tux almost everywhere because he'd had a landlord as a 24-year-old cub reporter in Washington who once told him you should always wear a tux in the evening because you look great, and if you don't like the party you're at, you can leave and people think you just got a better offer. You don't have a better offer tonight, ladies and gentlemen, and I'm glad those of you who came in a tux came from that other party. You're going to have a great time tonight. This landlord, by the way, was an antique dealer in Washington, and he specialized in antique maps. Actually, he specialized in taking knockoffs that he bought in London and Paris, burying them in the backyard for 2 weeks, then excavating them and selling them as antique maps. I haven't told our curators that, so Kirsten, don't get any ideas about things we should be doing. An institution like ours is often fortunate to have even one founder continue to be involved from the very beginning. And if that is true, then we are triply blessed to have not one, but three here tonight. 30 years ago this year, Gordon and Gwen Bell gathered a group of interested and passionate people to establish our predecessor, the Computer Museum in the heart of downtown Boston. Lynn has just recognized Gordon as a fellow, of course, but I want to pay a special founder's tribute to Gordon and to Gwen, both of whom are here tonight on behalf of everyone involved with CHM. Our third founder, of course, is Lynn Shustak, and you can hear a founder's pride in Lynn's voice on a night like tonight when he talks about our dinosaur, and rightfully so, because despite the economic turmoil of the last year, we have continued to grow in our programming and our ambition. We have launched a transformational phase of the museum just below us, directly below us, on the first floor in an area that you can't see yet. A 25,000 square foot permanent exhibition is taking shape on the history of computing, and you'll hear more about that later. You saw some of it on display in the cocktail party this evening. We spent much of this year celebrating the 50th anniversary of the invention of the integrated circuit, the sonic boom in modern computing, and the genesis of Silicon Valley. We have launched a new long-term education initiative with support from the Gordon and Betty Moore Foundation, the Severance Foundation, the Symantec Foundation, the Cisco Foundation, and others. And thanks to the generosity of many of the people in this room in this very difficult economy, we have raised now we have raised more than $4 million toward the new exhibition, and we have just finished our 14th consecutive year in the black. Much of this is a tribute to the patience and determination that Lynn and the board established from day one as our operating philosophy, and Lynn, to you in particular, we all say thank you for that tonight. There are 19 other museum trustees here this evening, and I'm told that may be a record. You've all supported the Fellow Awards in so many ways this year, and we're very grateful to you. Fellows represents the hard work and support of plenty of other people, and I'd like to just take a moment to thank them as well. First, along the lines of hardworking trustees, a special thank you goes to Ike Nassy of SAP Labs. Absolutely. Way to go, Ike. Ike serves as the chairman of the Fellow Selection Committee, which is a big job, It takes many months, but as you can see tonight, it always produces great results, and this year is no exception, so I thank you. Second is our Master of Ceremonies, David Pogue of the New York Times. I'll be welcoming you more formally in a while, David, so for now let me just say thank you and welcome. Next, our sponsors. We have 4 enormously generous lead sponsors tonight, Bill and Roberta Campbell, IBM, Intel, and SAP. We are grateful to them, absolutely. And to all the other sponsors you see on the screens here and in the listings in your programs. You have gone a long way to making the event possible. We say thank you and we welcome you tonight. I want to give special thanks to Corey Lyle, our Chief Marketing Officer, who really acts as the Supreme Allied Commander of Fellows, absolutely. And to Valerie Alston, who's walking around here with a walkie-talkie somewhere. I think she may be over there, who annually transforms this museum into this absolutely beautiful place. And finally, let me say thank you to our fellows, the class of 2009, Bob, Don, Federico, Ted, Stan, and Shima-san. It has been a pleasure to work with all of you in the lead up to this event. We're proud to induct you into the hall tonight, and we say thank you and congratulations to you all. A few of us have been treated to a sneak preview of the video profiles we're going to play of the fellows later this evening. Let me first reassure you, the fellows, that you come off very well. We're not going to embarrass you in front of your friends and family, and your face is going to be very large up there, as you can see. But I also wanted to say that while your accomplishments in fields of inquiry are highly diverse, your stories all share certain common themes. I'd like to describe them as a relentless belief that you were doing something to make the world better, an appreciation for the people and the teams around you, a wonderful tendency to vastly understate your own contributions, and most of all, an optimism about the future. When he was well into his 70s, Albert Einstein remarked that for a believing physicist, the distinction between past, present, and future was only a stubborn illusion. Tonight, all of us are fortunate to be reminded of that mysterious continuum by your words and your work, and therefore to be reminded as well why history is important and why we stop to honor those who have made part of that history. We will hear more about that and about the 6 of you as the evening progresses. For now, it's simply my pleasure to welcome all of you, invite you to continue to enjoy dinner, and the program will continue in just a while. Thanks and welcome.
When I was growing up, I read a lot of biographies and autobiographies. You know, I was fascinated by a lot of historical figures. The computer field was quite young, but already there were people like Ken Olsen, Gordon Bell, who'd done incredible work.
I think we've got a wonderful story. The evolution of computing has been a great thing, and I happen to believe that the computer is the greatest invention ever.
I like the history. Even before my time, machines that I had barely heard of, actually going and seeing what they look like, physical sizes, and looking at some of the nomenclature on the switches and thinking about the people that used them.
The semiconductor industry has made bigger changes in a few decades than printing has over a few centuries.
When I was a student at MIT, we all shared a computer. It took up half a building. It's an IBM 7094. Maybe it's here. It costs tens of millions of dollars. The computer on your cell phone today is 1,000,000 times cheaper and 1,000 times more powerful.
We are recording the events of history contemporaneously with them happening. Rarely in history do you have a chance to do that. Wouldn't you love to be able to hear Michelangelo talk about what it was like to paint the Sistine Chapel?
This is a remarkable place. I support the heck out of it. I really think it's an important thing.
That's what a museum is about, is being able to understand the history of what's been happening and to see it and feel it.
When I was a graduate student and I was complaining about the borough's architecture, my faculty member told me, study it. There's something exceptional in there that got it to be successful. You need to know what that is. That's what the Computer History Museum is all about.
So if that is what the Computer History Museum is all about, who are the fellows and what are they all about? The complete list of recipients is in your program, and as you scan them, or if you scanned them earlier, those names you may well see will help you understand why Lynn spoke earlier about the traits we seek to honor in our fellows. He dared to use words like cleverness and persistence, and yes, even genius, and I'm glad he did, because we like those words. And while we don't take those words lightly, words like genius, we use them with sincerity. Now make sure, make no mistake, they certainly are not the words the pioneers themselves would use to describe their accomplishments. To the contrary, you hear them say things like, I was very lucky, it wasn't me, it was the opportunities, or we invented this thing in a closet, nobody cared about it, we didn't have any guidance, or my favorite, I began to worry this was a little more complex than we'd first expected. It's a wonderful thing to me that such achievement is accompanied by such modesty. I mentioned Einstein earlier, and if you haven't read Walter Isaacson's incredible biography of Einstein, I definitely recommend it to you. Einstein once explained his achievements very simply. I have no special talents, he said. I am only passionately curious. In the 1930s, Einstein sought a meeting with a poet, Alexei Saint-Léger, and he asked a simple question. How does the idea for a poem come? Saint-Léger is said to have described it to Einstein as one part intuition and one part imagination. Einstein leapt out of his chair. It is the same for science, he said. It is a sudden illumination, almost a rapture. Later, to be sure, intelligence analyzes and experiments and confirms or invalidates, but initially, he said, there is simply a great leap forward in imagination. The fellows know something about leaps forward in imagination. And they also know a lot about that messy business that Einstein talked about, analysis, testing, trial, error, refinement. Often, as with the class of 2009, they work entirely behind the scenes. And in the case of breakthroughs like a general-purpose programmable microprocessor or SQL, their work enjoys today universal use, while the inventors themselves remain largely unknown outside the worlds of engineering and computer science and physics. Well, we aim to change that over time, mainly because these stories can and do inspire innovators of every age. Someone who understands that very well is our host for this evening, David Pogue of the New York Times. Of the New York Times is hardly the phrase to describe what David does. He is, of course, a regular columnist. His blog, Pogue's Post, is one of the most widely read resources for technology journalism on the internet. He produces a wonderfully creative channel of video posts on the Times website. He's won an Emmy for his work on CBS News, and he's a frequent contributor to Morning Edition on NPR. David is both an authoritative voice about technology and a sympathetic voice for the average guy on the street who's just trying to make sense of it all. He reviews the popular and even the slightly bizarre in new technology, and he isn't afraid to say what he thinks, and no one writes about it with more insight and good humor. And it's my pleasure, ladies and gentlemen, to welcome, and please join me in welcoming David Pogue.
Thank you so much. I begin tonight with a quotation There are a lot of museums that preserve things that are reminiscent of our culture. There's a Pez museum, a mustard museum, and a Barbie museum. Why wouldn't you want to preserve the computer, which is maybe the most influential piece of technology in the last 100 years? I'm sure you all recognize the quotation because you all saw my CBS News Sunday morning story where I interviewed your own Dag Spicer, the curator of this museum. That day when we filmed here was my introduction to this amazing place, and the visit left a real impression on me. I saw the first hard drive. Hint, it would not fit even into the iPod Classic. I saw the first Google server, and if it had been running, I'm sure I would have seen the first search for Britney Spears naked. I saw the Enigma machine from the war. It was almost enough to make me forget that I had just learned that there is a Barbie museum. So tonight is a worthwhile and important event. It's always struck me that the engineers and the computer scientists in this society do not get enough recognition. I mean, think about it. Yes, I see we have one in the audience. I mean, think about it. Think of the millions that sports people earn just because they were born with muscles. Think of, we scream and swoon over rock stars. We pay money to get on a bus to look at the homes of movie stars. But, what about the people whose labors we enjoy every day? Well, somebody wrote the software in the GPS unit that got you here, right? Somebody wrote the languages of the web that connect us all every day. Somebody wrote Windows Vista. All right, not the best example. Okay. Sorry. It's not like they're a sponsor or something, right? Oh, they are? Sorry. Wait till you see my review of Windows 7. All will be forgiven, I promise you. But you get my point. Where is the Facebook fan page for Bob Metcalf? Where are the 20-year-olds getting their tattoos on their shoulder blades of a scruffy Steve Wozniak? Where are the teenage girls with posters in their bedrooms of a half-naked Doug Engelbart? Listen, it'll take you a long time to get that image out of your head, I know. But Doug probably enjoyed it. On the plane from New York this morning, I was flipping channels on the seat back in front of me, which is itself a pretty amazing sentence, isn't it? And there was top chef, there was top fashion designer, there was top model. And I'm like, what is wrong with this society? All these superficial, fluffy things. Where is America's top computer scientist? Can you imagine how awesome that would be? They would have to do these stunts. You have 24 hours to recreate the original Wozniak ROMs for the floppy drive controller. You have a Commodore 64 and an audio tape. Go! I mean, you would watch that. And then when they let you go, instead of like, you've been voted off the island or take your knives and go, they'd say some cute tagline, your boot ROM has crashed. Abort, retry, fail. It'd be awesome. I'm launching a campaign to start this show right here, right now. Who's with me? Well, until that show finally gets off the ground, evenings like this is the best we can do. So let's do it upright. Now, it's not easy to become a fellow of this institution. As you must know, there were many, many submissions, many nominations. I think there's even an iPhone app for this. You have no idea how many worthy candidates were turned down. If we can go now to the screen. We turned down Alfred P. Dimwitty, the man who first had the idea of pushing the early laptop keyboards up against the screen, creating a palm rest. We turned down, the next ones are funnier. We turned down an enthusiastic nomination for Harvey Snodgrass, project leader of the team that created the BlackBerry shortcut, where you hit the spacebar twice to make a period and capitalize the next letter. Now inherited on the Trio and the iPhone and everywhere else. When are they going to put that in Microsoft Word? We turned down Melvin McGreevy, who introduced the arrow key arrangement known today as the inverted T cluster. Until that time, people had been suffering along with miserable arrangements like the inverted K, the inverted R, and the inverted W. The T worked much better. And finally, Charles M. Fredrickson, who actually conceived and proposed the iPhone in 1885. And nobody listened to him. None of them made the cut. But tonight, you'll meet 6 great minds who not only made the cut, but left their marks on history. Our first fellow, Robert R. Everett, graduated from Duke in 1942, got his master's in electrical engineering from MIT in 1943, where I'll bet he crossed paths with my own great uncle, Harold Edgerton of MIT, whom I called Uncle Harold Edgerton of MIT. After graduation, he worked for MIT's Servo Mechanisms Laboratory, developing hydraulic servo mechanisms for ship radar antennas. 2 years later, he joined forces with Jay Forrester to develop the Whirlwind computer, the first computer that operated in real time and had a video display as an output device. The Whirlwind is here at this museum. Well, a tiny piece of it, actually. The entire thing took 3 stories and required a fire extinguisher every 20 feet. Know how I know that? Dag Spicer, ladies and gentlemen, here at this end. Oh, thank you. One of my minions. In 1956, Everett joined Lincoln Laboratory, where he designed and tested the Whirlwind successor, the Air Force's semi-automatic ground environment, the SAGE air defense system, 250 tons, 60,000 vacuum tubes. It was the largest, heaviest, most expensive computer ever built, and the battery life was terrible. That's a joke. It was designed, of course, to coordinate radar stations and direct Air Force planes to intercept incoming enemy planes all over the country. This work led to the founding of the MITRE Corporation, which he joined in October 1958, stayed for 28 years, the last 17 years of it as its president. This new fellow is also a fellow of the IEEE, a member of the National Academy of Engineering, the Association for Computing Machinery, and he's served on many boards and committees. He's received enough awards to tip a bookcase, including honorary doctorates from Duke and Northeastern, and the National Medal of Technology presented to him by President George H.W. Bush. Tonight, we honor Bob Everett. In fact, we have a video that highlights his works and his contributions that have had such a meaningful impact on the evolution of computing.
To protect the future of America, the defense techniques of tomorrow had to be discovered now. They were discovered in electronics. You are listening to the heartbeat of the SAGE computer. Every instrument in this room is constantly monitoring, testing, pulse taking, controlling. All anti-aircraft guns, all defensive missiles in the area. And this computer is on the job around the clock with 24-hour-a-day reliability.
In the computer business and in the satellite business, reliability was the #1 requirement. If it was a choice between reliability and more performance, you took the reliability. Okay. You know, we pretty much did Whirlwind by ourselves, and including the Cape Cod system, but SAGE involved all kinds of people, including the telephone company, and the Western Elect was hired to build the buildings and put in the telephone gear and do the detailed hooking up. Various companies, IBM, of course, was hired for the computer, and there were organizations working on the radar monitors, and people built display scopes, which were special display scopes, and characterons, and Hughes built the storage displays. So there was a whole massive thing. So it became necessary to sort of invent our way into the system management of all this business. So I worked on whatever had to be worked on. I was sort of more like the chief operating officer, and looked on the crew and set them off on decided who worked on what specific jobs. I had to oversee the graduate students to make sure they got their theses done and things like that.
SAGE, with its display scope, also has one feature possessed by neither a television or radar screen. It has memory. In case of enemy air attack, not only can a clear picture of the changing air situation be displayed on the scope, but if the airman wishes to see how things got that way, the scope can recall any previous phase of the situation from the computer's memory. By analyzing the past, SAGE can project into the future.
They spun off Division 6 and, well, most of Division 6 and some other pieces that were working on SAGE, and formed the MITRE Corporation. And the initial job was to continue to attend SAGE. Now, those of us who went to the new corporation knew that wasn't a lifetime's work. ICBMs were very important. It looked like air defense was a losing business. But there were obviously lots of other things to do. The MITRE Corporation was formed and has since been working on information systems of all sorts for everybody, and gotten a lot bigger, and still works on air defense. The thing to do is to find a job where you have opportunity for experience, to learn things, to do things. Let the future after that take care of itself. I was very lucky. I don't know how many opportunities there are like I had. It wasn't me, it was the opportunities.
The 2009 CHM Fellow Award is presented to Robert R. Everett for his work on the MIT Whirlwind and SAGE computer systems and a lifetime of directing advanced research and development projects. Sadly, Mr. Everett could not join us this evening. However, we have the world's best person attending in his behalf, his grandson, Matthew Everett, who went to the same college, MIT, lived in the same dormitory, received his degree from the same department, graduated, went to work for the same company, Lincoln Labs, in the same division, in the same building. If anyone can stand in for Bob Everett, it's Matthew. Please welcome him to accept the award on Bob's behalf.
You guys are thank
you. Did you have red eye turned on? Because it's going to be a nightmare out here. Okay. Sorry, reflex. Our second fellow honoree tonight is Don Chamberlain, who's best known as the co-inventor of SQL, SQL, the structured query language, the world's most widely used database language. It's interesting, I believe that he himself pronounces it SQL, even though it's spelled SQL, making Don the first person to know how to tweet even before Twitter was invented. Pretty cool. He developed SQL in the mid-70s with Raymond Boyce, and it became the first commercially successful language for relational databases. Mr. Chamberlain grew up in San Jose. He got his engineering degree in 1966 at Harvey Mudd College and his MS and PhD in electrical engineering at Stanford. You might have heard of it. After 2 years working for IBM in New York, he returned to San Jose and continued his work at IBM's Almaden Research Center. You're the Almaden table. Give me a thumbs up. Okay. Where he was named an IBM Fellow in 2003. Chamberlain was named an ACM Fellow in 1994 and an IEEE Fellow in 2007. Are you allowed to be a fellow of so many different things? Yeah, okay. In 1997, he received the ACM SIGMOD Innovations Award and was elected to the National Academy of Engineering. In 2009, he was appointed a Regents Professor at the University of California, Santa Cruz. Today, he passes on his love of programming to his students there, and he contributes problems and he judges the ACM programming contest. His website, I note, includes photographs of himself sailing sunfish, riding his motorcycle, and whitewater rafting, although not all at the same time. Tonight we honor Don Chamberlain with this award and with this video, which highlights his contributions to the evolution of computing.
I think the thing that got me interested in science and technology as a career was all of the emphasis on technology that was going on in the late 50s as a fallout from the Sputnik launch, the Russian satellite. There was a sense in the country that technology was important and that we were falling behind and losing our edge, and that I had an idea that technology was a way to do something important and to make a contribution that would be respected and recognized and appreciated and rewarded. And by and large, I think that's turned out to be true. SQL was done sort of in a closet. It was done by Ray Boyce and myself with some help from Ted Codd and some other people in the research division at IBM. Nobody cared about it. Nobody tried to influence it. It just belonged to us, and we could do anything we wanted to with it. We didn't have any constraints. We didn't have any guidance. We made a lot of mistakes that eventually were corrected over the years as the standard continued to evolve. So it was a smaller and more personal process, and we had more control over it. To be successful, you need two things. You need to have an opportunity, and you need to be prepared to exploit the opportunity. And these two things came together in a very synergistic way. I think the state of the industry being sort of at the right time, receptive to these ideas, and Ted Codd's breakthrough ideas provided the opportunity. And I think the brilliant people that were assembled by IBM Research to work together, Jim Gray working on transactions, Pat Selinger working on the optimizer. Each of the individuals who was involved in the System R project, and there's over time probably 20 of them who made spectacular intellectual contributions to this work, who proved that these ideas were not daydreams, but were of practical significance. And I've never been in a place where there were so many smart people working so productively. So what I would like to do at this point in my career is to try and pass along some of the enthusiasm that I have for computing as something that's fun to do and a powerful influence on the world to young people.
The 2009 CHM Fellow Award is presented to Don Chamberlain tonight for his fundamental work on SQL and database architectures. Please join me in welcoming Don Chamberlain. Looks kind of like a high-end shampoo bottle. It's very, very cool. Sorry, that's just an observation. Our final four fellows will be inducted as a group, but what a group. This is the group responsible for the world's first commercial microprocessor, the computer on a chip, the Intel 4004. I'll introduce them to you in hexadecimal order. Sorry, alphabetical. Sorry, alphabetical. First, Italian physicist and electrical engineer Federico Fujin joined Intel in 1970, where Ted Hoff, Stan Mazur, and Masatoshi Shima had designed a new architecture for a family of calculators for a Japanese client called Busicom. Fujin was hired as the project leader to implement this architecture. With Shima's help, he designed and developed all four chips in the 4004 family. He went on to co-found Zilog in 1974 and Synaptics in 1986, and then became president and CEO of camera sensor maker Foveon, evidently feeling that his resume still needed a little bit of work. He holds a doctorate in physics from the University of Padua. Ted Hoff joined Intel in 1968 as employee number 12. I believe it was much easier to find parking back then. He is credited with devising the idea of a programmable processor to replace custom-designed circuits, although he and Stan Mazur had proposed that architectural idea in 1968. Hoff earned his bachelor's degree in electrical engineering from Rensselaer Polytechnic. He received his first 2 patents working at a summer job during his college years. So next time you guys are feeling overly accomplished, way to make us feel great, Ted. He received his master's degree and PhD at Stanford. Stan Mazur grew up in Oakland and went to San Francisco State University. After a stint at Fairchild, he joined the 1-year-old Intel Corporation to work under Hoff on that BusyCom calculator project. Mazur assisted in its architecture and wrote software for it. And finally, Masatoshi Shima was an employee of the above-mentioned BusyCom calculator company. He worked with Hoff and Mazur to define the functional specification for the 4000 series. He took charge of the chip's logic design, logic simulation, and test program generation. He holds a bachelor's degree in chemistry from Tohoku University and a doctorate in engineering from Tsukuba University. Apparently nothing in here about Stanford. But in 1997, Shima shared the Kyoto Prize with the 4004 co-inventors Hoff, Fajin, and Mazur. Tonight, we're very proud to honor this team, but first we'd like to introduce you to them in our final hard-hitting video.
Nearly 40 years ago, Intel developed the world's first computer on a chip. Tonight, we honor the team of Fajin, Hoff, Mazur, and Shima, who spearheaded this development. This special chip, the Intel 4004, began as a custom design for a Japanese calculator maker, but became the cornerstone of our modern civilization.
We were contacted by a Japanese calculator company that sold calculators under the name BusyCom. They had a fairly complete design for a family of LSI chips that they were going to use to actually make a whole series of different calculator models.
BusyCom decided to develop a general purpose LSI family that would be used for not only a desktop calculator but also a business machine. BusyCom chose Intel as a co-developer because Intel has already developed an advanced high-density and high-performance silicon gate MOS process technology.
I had not seen any specific description of the LSI, and I did not see that until Mr. Shima and his team of engineers came over in June. I started to have some concerns that this may be more complex than we had expected. And I expressed some of these concerns to Bob Noyce, and he said, well, if you have any ideas to simplify the design, go ahead and pursue them. Around the 1st of September, Stan Mazur joined my group.
Well, when I joined Ted in September, he had pretty far along with an alternative design consisting of a ROM chip, a RAM chip, and a CPU. So we ended up with a 3-chip design. So part of my job with the office mates was to take snippets of code and go over some of the features that they needed in their calculator and figure out how we do it in, quote, software.
So what happened next is that, I have now this task where I am essentially 6 months late, the day after I start. I have 4 chips to develop, an angry customer, and basically Intel had no experience whatsoever in designing random logic circuits, particularly with silicon gate. I designed all the basic building blocks that we're going to use for the family, and then I combine the logic design and the circuit design into a single document, so the transistor would be put as close as possible to their physical location in the layout.
But to do that, I needed an engineer to help me and also adequate layout and technician support. I was by myself. I had no engineers, no layout people. That's it. I had to do it by myself.
The microprocessor has transformed nearly every aspect of modern life. It's let us create entirely new products, and it connects us in ways only science fiction dreamed of. Today, almost everything with a battery or a power cord has a microprocessor inside. Join me tonight in celebrating the accomplishments of this remarkable team.
The 2009 CHM Fellow Award is presented to Federico Fujin, Ted Hoff, Stan Mazur, and Masatoshi Shima for their work on the 4004, the first commercial microprocessor. Nice to meet you. Congratulations. If you had bought 1,000 shares of Busicom in 1970, today it would be worth nothing. Thank you.
David, thank you. It's a tradition, a new tradition, but it is a tradition at the museum now that we typically ask one member of the class to come up and say a few words on behalf of everyone. And this year we're going to ask Don Chamberlain to come back up and represent the class. Don, thank you.
I've been asked to make a few remarks on behalf of the Fellows Class of 2009. On behalf of all of the honorees, I'd like to thank the museum for this great honor. Believe me, it's a humbling experience to be named a fellow of the Computer History Museum. I'd like to also say how fortunate all of us feel to have participated in the digital computer revolution. Once in a while, maybe once in a generation, a technology comes along that affects our culture in a profound and fundamental way. And the people who worked on the early days of railroads or radio or nuclear fission probably felt that they were at the center of the action for their time. And I think history will show that in the last half of the 20th century, the most important thing that was happening was the development of digital technology. Within my lifetime, the first bit was stored on a magnetic disk. Now, of course, magnetic and electronic bits are the basic medium for storing information and exchanging resources in our civilization. Information, which was once scarce and expensive, is now ubiquitous and free. It's been a great privilege for each of us to have played some small role in this transformation. And I think everyone in this room attending this special event owes the Computer History Museum a debt of gratitude for preserving the stories and the artifacts of the computer revolution, which might otherwise have been lost. So once again, thank you from the Fellows Class of 2009 to the Computer History Museum for the great honor of including us in this esteemed Hall of Fellows.
Don, thank you so much. Congratulations, and congratulations to all of you. It's wonderful to have you here. And for you Stanford grads, David Pogue is staying at the Four Seasons, room 417. Feel free to put your redial buttons on every 4 minutes. Now, 2 closing words about things to come here. First, an important milestone will be celebrated in 9 days. On the 29th of October, 1969, the first message was successfully transmitted between the first two nodes on the ARPANET. At each end were Bill Duvall and Charlie Klein. Doug Engelbart, Larry Roberts, Paul Barron, and Severo Ornstein are among the many who seized upon that moment and helped fashion it into the revolution that today sees a fully connected world. All of them are with us tonight. 40 years later, and in our programs over the next year, we will explore how the globally connected society came about and the implications for our future. I hope you will join us for this anniversary series next year. The last item on the agenda tonight is a brief preview of the Computer History Museum version 2.0. I mentioned earlier that we're building a permanent signature exhibition to showcase the history of computing from the abacus to the smartphone and everything in between. This exhibition has been 6 years in the making, and it is being made possible through the enormous generosity of the computer industry in the Valley, with a lead gift from the Bill and Melinda Gates Foundation. Here's what's coming up. The Computer History Museum is planning a major new expansion in 2010. The museum will now host a new permanent exhibition designed to tell a comprehensive story of the history of computing, from the abacus to the smartphone and everything in between. The $17 million expansion will fill more than 25,000 square feet. It will feature 19 exhibit areas and state-of-the-art digital theaters. More than 1,500 of the museum's best artifacts will be on display. The exhibition will be a rich multimedia experience, reminding our incomparable archive of film, images, and never-before-seen photographs to bring the technology and story of computing to life. We'll produce more than 75 historic films, work that will include rare footage from corporate archives, vintage interviews with legends from the computing industry, and many of the museum's own fellow awards recipients. The exhibit will look and feel contemporary, engaging, and alive with history. It has been more than 6 years in the making and is set to debut in the fall of 2010. Where will you go to see Silicon Valley? The answer is the new exhibition on the history of computing, coming this year at the Computer History Museum. I want to thank... As you can see, the museum is on the move, and so is this dinner. We're going to move downstairs now onto the first floor gallery. We're going to have dessert and drinks and coffee and cognac and cigars. Our newly inducted fellows will all be there. I hope you'll take the time to congratulate them. Most of all, I hope you'll feel free to stay, to catch up with your many colleagues and friends and enjoy yourselves. And on behalf of the trustees and the staff and everyone at the Computer History Museum, thank you so much for being here tonight, and we'll see you downstairs in the gallery.